Hello students, greetings of the day. Now the chapter Units and Measurement is complete and I am going to introduce you to the new chapter which is Motion in One Dimension. You will feel very connected to this chapter as you are studying this from class 9th itself. This is very important also because the concept you learn here will be helpful throughout the session of physics. So let us start our classroom session with this new chapter.
Motion along a straight line. Here we have to discuss all the things, all the aspects of motion. We will discuss every single kinematical term. We'll learn how to solve the numericals based on this, and by the end of session the concepts and everything will be crystal clear to you. So let us start with the term kinematics. When we say that we have to study motion without bothering about its cause, it comes under kinematics. Now what is cause of motion? Cause of motion is force. Without force no motion can be started. So when we are studying only the motion without bothering about its cause, then it is called kinematics. So motion comes under kinematics. Here it is specifically motion along a straight line, because motion can be in 1D, it can be in 2 dimension or even in 3 dimension. But here for this topic we have to consider only when motion is along a single direction. Let us say if I have to move along north, I will continue moving towards north only. So then this kind of motion is called motion along a straight line. If I am moving towards left, so I will continue moving towards left. This kind of motion is motion along a straight line. So let us first see how is motion studied, how is it analyzed. For analysis of motion, reference frame is needed because motion itself is a relative term. Without a reference, we cannot analyze the motion. So motion is a relative term. It has to be with respect to an observer. When I am saying that yes, this bus is moving, so I am the observer, I am the reference frame. Any frame which is attached to the observer is known as reference frame. So motion cannot be studied without help of reference frame. Someone has to be there to analyze the motion, which can see that yes, position is being changing with time. So motion is a relative term. Though in the session how relative velocity or relative displacement or relative acceleration will be dealt separately, but motion itself is a relative term, and whenever we are saying motion, of course we are saying if it is not relative, it will be with respect to ground. There is nothing like the absolute motion. Understood? So for motion there has to be some reference frame attached to it. Now let us come to the kinematical terms. So many kinematical terms will be involved throughout chapter. So let us first write what is scalar and a vector, because we are going to study some of the kinematical terms. Some of them will be scalar, some will be vector. So first let us see what is scalar and what is vector. If I say that the car is moving with 30 km/h speed, if I am saying this, so I am interested how fast is car moving, only in its speed. So if this kind of interest is there, then the physical quantity which is involved is scalar. So scalar is something in which direction is not desired, it is not needed at all. We are concerned only with the magnitude. So scalar quantity is a quantity which has concern only for its magnitude. Whereas the vector, if the same example I am saying that this car is moving with 30 km/h, but it is moving towards north. So here I am specifying the direction. If direction is also concerned along with magnitude, then it comes under vector. So here it has to be magnitude as well as direction. Magnitude plus direction. Of course, one more thing is there, that if a physical quantity is a vector, it must follow the vector algebra, otherwise it won't be a vector, because we know that there is an example which is current, which has magnitude and direction as well, but still it is a scalar because it does not follow vector rule of algebra. So here, as far as kinematical terms are concerned, no such quantity is there for which direction is there, but still it is not a vector. And we are here concerned only with the kinematics. So scalar is something which has only magnitude and vector is something which has both magnitude and direction. Now let us see what kinematical terms are there which comes under scalar and other comes under classification of vector. So here we will see path length. Sometimes it is written as distance traveled also. So path length or distance, whatever, both the terms are same. This is a scalar quantity. The next is speed. As just now I had taken the example that speed of car is 30 km/h. So without specifying the direction, if we are interested in its speed only, how fast the thing is moving, then it is a scalar. So speed is also a scalar. Next come to the vector quantities. The path length is there in scalar and the corresponding vector term is displacement. Displacement is something for which direction is also needed. It has nothing to do with the path length. And the corresponding term for speed is in vector, this is velocity. So velocity is when speed is associated with a direction, then it is called velocity. One more term is there which is acceleration. This also necessarily is a vector quantity. Next term is acceleration. Now let us move each of the kinematical terms, and do remember kinematics is something which is without the cause. This is study of motion without the cause, so it is without the force. So here in the topic we are not going to discuss force anywhere, just we are interested in the motion. Now the kinematical terms are there. As you can see here, one is distance, other is displacement. Let us take one example. This is your home and here is your school. So if you have to go to the school, you can take this path. Directly you can go to your school. This is your home and the school. Directly you are going to school. Some other student may be there which first goes to gym and then school. One other can be there which goes first to a shop to buy some stationery and then goes to the school. So what is different among these three paths? Of course, path length, if you see, it is different because one is traveling directly, he is going from home to school, so the shortest path length he is taking. The other one, first he is going from home to the gym and then to school, so this is somewhat different path length. The third one is taking another path, so here also path length will be different. So here for all the three, because source is the same, that is home, destination also is the same, that is school, but for each student path length is different. So the kinematical term distance is simply the path length. If we are interested in that how much one has traveled, then of course it will be different for all the three students. For this, if he is going to school, it can be 2 km. For this student, it can be 4 km. And this, it can be 5 km. So path length, if you see, it is different. Now come to the displacement. Displacement, what is displacement? Displacement is simply shortest distance from initial position to final position. So displacement is something we generally write displacement by delta S, put a vector sign above because it is a vector. So that is equal to R final minus R initial. It has nothing to do with whether from the home you are going directly to school or going via gym or going via some shop, right? So displacement for all the three students is same because it has nothing to do with path. Directly it takes consideration of the origin and the destination, and this is the shortest distance traveled from origin to destination. So displacement is independent of path. You can say it's a vector quantity. This is independent of path. Whereas the path length, of course, it is showing the length of path you are traveling, so it will depend on path. There may be cases when if we represent distance by term d, then d will be equal to, it can be equal to magnitude of displacement. This is possible when the student directly from home he is going to school. So this distance can be equal to displacement, but of course this will not be always true. So distance can be more than displacement also. As you can see here, for second and third number of student, distance is more than displacement. Is it possible that distance is less than displacement? No, this is simply not possible, because displacement we are defining as it is the shortest distance between the origin and the destination. So displacement never can be more than the distance traveled. This is simply not possible. Here we learned about the difference between distance and displacement. Let us now come to the next kinematical term, which are speed and velocity. The difference that is between distance and displacement, the same difference is between speed and velocity. So what is speed? Speed is the path length traveled upon time taken. This is path length upon time taken. Whereas velocity, it's a vector term. So velocity is, this is displacement. Displacement we had denoted by delta S. So displacement upon time. As you can see here, speed is a scalar term and velocity is a vector term. Speed has nothing to do with in what direction a thing is moving. It has to do only with how much distance it has traveled in what time. But velocity has to take consideration of both the direction and the length of path also. So this is the difference between speed and velocity. If we write it mathematically, speed, if you denote by v, that will be equal to path length, as we had denoted with d, path length as d, then this is d upon time. So this is how speed and velocity is mathematically represented. The same difference is between distance and displacement. So speed is a scalar term and velocity is a vector term. Here you can see, as velocity is a vector term, so this can be negative, because if we are saying that north direction is a positive direction and you are moving towards south, then velocity will be of course negative. Speed can never be negative because it has nothing to do with direction. So whatever be the magnitude, it has to be positive only, because if someone is traversing a distance, that will go on increasing. So speed always will be positive, whereas velocity can be positive as well as negative. As we had seen just now that speed can be equal to magnitude of velocity. Yes, this is true. It can be. If someone is following a straight path, speed will be equal to the magnitude of velocity. But if the path is different, then of course speed will be more than the magnitude of velocity. Is it possible that speed is less than velocity? No, again this is not possible. So speed cannot be less than magnitude of velocity. Understood? So now we can write collectively as speed can be more than equal to the magnitude of velocity. Now I will introduce two more things. Speed can be written as, it can be categorized as average speed and instantaneous speed. So one is average speed, the next is instantaneous speed. As the name suggests, what is average speed? Average speed is, let us say one example, that you have started from this point A. Now your speed is, first you are going to B, the distance of which is 1 kilometer, and you are taking 10 minutes. From B to C, the distance is 2 kilometer and you are taking 15 minutes. So if someone asks what is your average speed, then it has to do nothing with at which point what speed you are having. It has to take the whole journey into consideration. So average speed will be mathematically expressed as total distance traveled upon total time taken. So this is distance traveled upon time. Now come to this term instantaneous speed. As you can see, it is instantaneous. So it has to be some specific instant. If someone is interested in that at 5 minutes, what was your speed? Then that value of speed will be known as instantaneous speed. So mathematically, if you write, it will be ds upon dt. If s is the distance traveled, so we have to take very small differential part of distance, and of course this will be traveled in very small time, so it has to be ds upon dt. This is known as instantaneous speed. So don't get confused among these two. Average speed is total distance traveled upon time. It has to do with the start of journey and the end of journey, whereas the instantaneous speed is concerned only for a particular instant. So this is difference between average speed and instantaneous speed. The same difference we can write for velocity as well. The same we can understand for velocity also. So average velocity can be written as the average velocity, it has to be total displacement upon total time for the entire journey, the resultant displacement. Now the path can be even irregular, but it has to do with the total displacement, final destination point and minus position of initial point, this divided by the whole time taken, that will be average velocity. It is of course a vector term. Next is instantaneous velocity. Again, as we had discussed for instantaneous speed, the instantaneous velocity also has to be concerned only with a particular instant, velocity at a particular instant. So that would be, this is the average term, and the next instantaneous will be equal to ds upon dt. So it is for a very small differential interval of time. Distance traveled also is very small, that is ds. This is the way we represent average and instantaneous kinematical terms. Average velocity, instantaneous velocity, average speed and instantaneous speed. The next kinematical term is acceleration. Acceleration is rate of change of velocity. So this is rate of change of velocity. Does this happen that if you have to go from your home to your school, even if you are going through a straight line or through some curved path, whatever be the path taken, but is it possible? Generally it is not possible that continuously you will continue moving with the same speed. Generally it is not possible. You may stop in the meantime, you may stop at some, or you may slow down at some instant. So there is continuous change of velocity throughout the journey. This change of velocity, if we see with respect to time, that is known as acceleration. So there can be two kinds of motion where velocity is uniform. Like if you have started from home, with the same velocity you will reach the school. So it will be throughout the journey, the velocity will remain the same. So that is velocity. If it is uniform, then there is zero acceleration. No acceleration term will be there, because there is no change in velocity. As I have said, acceleration is rate of change of velocity. So if velocity itself not changing, then of course acceleration will be zero. The next, it can be non-uniform velocity. Non-uniform velocity is when after the breakfast you had just started, your speed may be more. So maybe you are moving with 5 km/h. Then with time you got somewhat lazy and then your speed starts decreasing. So that is the case of non-uniform velocity. Then of course it will be having non-zero acceleration. So acceleration can be zero or non-zero depending on whether velocity is uniform or not uniform. Now let us again define two acceleration terms. One is average acceleration and the other is, as in all previous kinematical terms, the next one will be instantaneous acceleration. So average acceleration, as you know, it has nothing to do that in the journey, this may be possible that you started from home with 2 km/h. After some time, your speed got reduced to 1 km/h. Then in the meantime, you may even stop at some shop and then again you started, and then when you saw that, oh, time is very less now, so you started running and your speed has become very high. So it has nothing to do with these all incidents. With what speed you are reaching the school minus the speed with which you had started, that is change in speed. So average acceleration is final velocity minus initial velocity. this whole divided by the whole time which is there for the whole journey. So average acceleration has to do with the total change in velocity, this divided by the total time taken. What about the instantaneous acceleration? Instantaneous acceleration is concerned with only a particular instant, that in some particular instance, in some specific instant, what was the change in velocity when you were changing from 1 kilometer to 2 kilometer, or you were changing from 2 kilometer to 0. So instantaneous acceleration is mathematically, if you write, it will be a very small change of velocity in, of course, very small time span. So this is how mathematically instantaneous acceleration is represented. Now the very important and very interesting part of kinematic is graphs. Whatever be the exam you are preparing for, the questions will be there from graph in this kinematics chapter. So let us see how are the graphs drawn, how does it is interpreted, and how numericals are solved with the help of graph. So let us start with distance time graph. The first thing we are going to learn about is distance time graph. First thing is distance time graph. When we draw a graph for kinematical terms, generally on x-axis is taken time. So here I am concerned with distance time graph on x-axis, as just now I have said that on x-axis time is generally taken. So let us take time on x-axis, then of course position on y-axis. The direction can be anything because we are studying motion in a single direction. So that direction can be x direction, y direction, z direction, or any other direction. So here I am considering that motion is being along x direction. Whatever be the direction of motion, you can assign x or y or z direction to that value, to that direction. So here I am assigning the direction of motion as x, and of course then x versus position versus time is being drawn here. Let us now draw the graph. There can be a number of ways in which a graph is drawn. So let us start with the most simplest straight line graph. Right? Now as you can see, this is x versus t. As we all know, equation of straight line graph is y is equal to mx plus c, where c is the intercept and m is the position. Here graph is between x and t. So it will be between x and t. On y-axis is x and then x-axis it is t. So what does this mean? This m is slope here and this c is intercept. This intercept on y-axis. So it is written as y-intercept. Here we are drawing graph between x and t. So equation will be written as x is equal to mt plus c. What about c? This is y-intercept, and here on y-axis we have taken x, so it is actually x-intercept in the given graph. What is x-intercept here? As you can see, it is passing through origin, so this intercept is reduced to 0. Now the graph is x is equal to mt. If you write m here, that will be equal to x by t. What is x? X is position and t is time. So position by time. What does it represent physically? So this has to be velocity term. Now you can see the slope of a distance time graph is represent velocity. So velocity is represented by slope of distance time graph. X versus t graph. Got it? As in the given graph, you can see that slope is throughout constant. You must be knowing how is slope calculated. Either it can be calculated as, if this angle is theta, then it can be calculated as m is equal to tan theta. Either you can calculate slope like this, or you can write the simple method, that is the general method, that is change in x upon change in t. So these are the two ways in which you can write your slope, and here slope does mean the velocity term. This can be written tan theta as well. So it depends on how the question is Given, you can write even tan theta or delta x by delta t, and slope will be represented and velocity will be represented. If your graph is like this, here it is not a straight line, it's a curved line. So position is not changing linearly with time. What does this graph interprets? Here if you see the slope, first it was 0, then it started increasing. So the slope got increasing. What does it mean? That velocity gets increasing. So here this is the graph when velocity is not uniform. So this is non-uniform motion. Where velocity is not uniform, it is called non-uniform motion. So this is the graph for non-uniform motion. We will solve a number of examples based on the graphs in our coming session. Bye.